Hi everyone, I hope you are doing good. So today in the DSA question series, we will discuss one question which is recently asked in one of the interview. So in this video, what we will do first, we will understand the question here with multiple examples. Then we will discuss the algorithms, right, that can be used to solve this question. And then we will implement that algorithm into the C++ code, and we will run the multiple use cases there with that C++ code. So let's start with the question here first. So the question is given a grid of n cross m, right? So we will have a grid of n cross m kind of matrix only, right? N will represent the rows and m will represent the number of columns here. And this grid will consist the 0 and 1, right? 0 means water and 1 means land. We have to find the number of islands, right? Islands means the land which is surrounded by the water. That is called island, right? So that is, I hope you know it. So we have to find number of islands which can be made using the given matrix, or in the given matrix you can say. An island is either surrounded by water or a boundary of a grid, right, and is formed by connecting the adjacent lands in all 8 directions. See here, all 8 directions means, so directions could be like vertically up and down, horizontally left and right, and diagonally, right, diagonally in the 4 directions. So all the 8 directions we have to check for the water or the land, right? So let's take this example here. So here it is given a grid. So let me write here grid 0, comma 1. So this is the grid it is given here, and here boundary means water you can say, right? If it is going beyond the boundary means we will consider a water, right? And if 0 means water and 1 means land. So here you can see like this one is connected to this one, right? This is connected to this one is connected to this one, this is connected to this one, you can say, right? And this is also connected to this one. These both are connected to each other, correct? These are also connected to each other, you can say. So now we can say the land is this one. It is one island which is made of this one, right? This one. So this is one island we have here. So in this case, the output would be 1, correct, you can say. So we have to implement the algorithm, we have to find the algorithm, we have to find the approach which can find the number of islands in the given matrix basically. So that is our question. I hope you understood it. So just pause the video and think about it. How can you find the number of islands using the given matrix or in the given matrix, right? So let me explain my approach. What I am thinking is, what we can do.
1, go.
We can use the previous approach which I have discussed in my last video. If you haven't watched that video, please go and watch that video, because there I was counting the X shapes, right? There in that matrix we were having X and O. Here we are having 0 and 1. Right, I hope you can connect that video with this video, right? And there we were checking for the 4 directions, right? Vertically up and down, and horizontally left and right. So 4 directions we were checking in that video. Now in this video, in these questions, we are considering all the 8 directions, 4 horizontally and vertically, and 4 directions diagonally basically, right? So here we are checking 8 directions. So if you have watched that video, right, then this question will be very easy for you. So now let's discuss the solution for this approach here. So I have here two functions. The first function is this one, and the second one is this one. This is the helper function. It is used for the connected islands, right? And this is for the basically counting the number of islands, right? Basically checking all the values in the given matrix. So what I'm doing here, I will go and check the first node here. So this is 0. So we cannot no need to take care of this 0, because 0 means water here, right? And then we will go and check the 1 here. So 1. So this is the 1, means this is the land. So now here Iceland can be 1, right? So the count of the result, or you can say the count, right? Count is 1 here. Now then again we will check for the all the connected lands to this Iceland 1, right? This land 1. So now here what we will do, we will check all the 8 directions here. So here I am updating here the result count, right? That is 1, and then I am calling this update all connected islands to 0. So whatever the connected lands to this one, we will make them 0, right? So now here I'll go this function, and I have checked here the base condition, because this is the recursive functions. That is why I am using the base condition here. Means if we are going out of boundary, then we will just return, or if we are having the visited node, or you can say that water, then we have to also come back, right? So here this condition is false first time, because the grid of R comma C, right, row and column is 1 here. This is 1, right, and this is valid position. So here I am making this to 0. So I am updating this to 0, right? And then what we are doing, I am going for the here row is row comma column plus 1, means I am going right side, right? And I'll go, and this is basically going out of boundary. This condition will be fulfilled, base condition, so we will come back here. So we will come back to here 0, and then we will check this one, right? This is means right comma down, right down, basically this condition, this direction is right down, you can say. So here this is also going out of boundary, so here we will come back, and then we will check down. Down is water, so we will come back, and then we'll check this one. So this is 1, so we will go for this node here, and we do the same things here. Then we'll and then we will go for this one right here, and for this one also we are connected like up, this up, right, then this right, right down, and then down is water, right? We will come back, we will not do anything here. And see this one, this is 1. So now we will go here, and we'll check all 8 directions here. This one, this one, this one, right? This one, all are going out of boundary, either going out of boundary or 0. And then the above one, right? So here, then the above one is 1, so we'll go this one, right? And while basically iterating, we are making those 0, right? So these are 0 now, correct? And here we will check all the 8 directions, right? This one is 0, this one is already, we have updated to 0, right? Below this one, all the 8 directions, and this is already 0, right? So now we are done, and now we will come back. We will come back here, from here, then we will come back here, right? And we will come back here, and then we will return back to from this main function here, where we are updating the count. And now here we have checked for this position. So now we are done with this position. Now we will check for this one. This is 0 because we have updated to 0. Now we will go to this one. This is 0, right? Now this one is also 0, updated to 0. This one 0. All are 0 now. Means, and then once we are done with all the once we are done with the visiting all the nodes, then we will return the result, whatever result we have, and the result is 1 here. I hope you understood it, because here recursively, if you know the recursive programming, if you have any doubt, any question, any query, or you are getting like hard to understand the recursive programming, then just comment below the video. I'll have a separate video for recursive programming. I am assuming that you know somewhat recursive programming, and you have watched my previous video where I have explained the except counts, where also I have visited the we were checking the 4 directions, horizontally and vertically. So this is the one approach we can go with. The second approach you can take is you can have a separate matrix, right? I have discussed in last video, and you can also try with that. So where what you have to do, you have to take a separate matrix, right? Initially you can take a value either false or true, whatever suits you, right? And then once you visit, then just toggle that value in the separate matrix, right? Where we will store the visited nodes, and using that also you can solve this question. So I hope you understood this algorithms. It is very simple. You just have to keep in mind that there are 2 tasks here. One is visiting all the nodes, right? All the lanes, and then once you are on land, then check for the all the connected lanes to that current position, basically current position or current land, you can say, right? And while finding all the connected, you just make the current to 0, so that you it cannot be visited twice, right? So that is what you have to do, right? And for that, the first this function is using for all the traversing the each and every basically position, right? And this one is for the all the connected lanes to that position. That is what we are doing here. Let's go through the code. I have implemented this algorithm into the C++ code, so let's go through that, and then there we will run the some use cases. So here you can see the C++ code where what I am doing. So here we have main functions in which we are taking some inputs like number of test cases, the size of matrix, and the matrix element. And here you can see this is the functions which we discussed, right? Here these 2 loops I am using to iterate to visit all the nodes, and then for each and every node which is having 1, right? 1 means land, right? So if it is having 1, in that case what I am doing, I am just updating the count of the Iceland, right? This is our result which will show the count of the Iceland, right? 1, and then for that particular position I will pass to this function. Here in this function, what it will do, it will check all the 8 directions and all the connected basically lands to this one in all the 8 directions here. So see here, 1, 2, 2, 3, 4, 5, 6, 7, 8. So here I am checking all the 8 directions if it is having any connected lands or not. right? So that is what I am doing here. So here it would be row, then column plus one, means this is right directions. Then the second one is here, row plus one, column plus one, right? Means we are going basically right down, right? You can say, or down right, you can say, right? And then this one is here we are updating we are adding one plus to the row. So we are going down here because column is zero, right? And here we are having this is left down, right? And then this one is we are checking for the left, right? We are basically subtracting one from the column, and here we are subtracting from the column and also from the row. So it is basically up left, right? You can say, and this is up, and this is up right. Correct. So here I am checking for the all eight directions, and before that I am making the current node to the zero, so that it can like it cannot be visited twice. Right, to avoid this situation, I am making it to zero here. Instead of this one, so this is one approach, right? We have discussed. I'll run the use cases with this one also, and then I have another approach. So this is the optimized one, and the time complexity of this one would be order of n square, right? And space complexity would be order of 1, because we are not using any extra space other than the this call stack of the recursive, right? That's all. Now here what we are doing, if we use, we can implement this algorithm using the separate matrix also. You can say DP or whatever you want to say, right? So here what I am doing, I am taking here two arrays of 8 elements here. Basically, these are the helper arrays which will be used to calculate the directions, right? Which directions we have to check. So here what I am doing, I am using a loop here for 8, right? Uh, and here this function is used for the making the marking the node to visited, correct, in the separate matrix, and the separate matrix is this one, you can say DP. So DP, I am taking a separate matrix of the same size of as the grid, whatever the grid we get, right? And here initially all the grid is having false. So initially this DP is having all the values as false. Once we get one, right, true, right? Once we get a grid of I comma j is 1, in that case what we will do, we will and the value is false, then we will make it to true, and we will update the here Iceland count, and we will pass this DP and the position to the helper function here, which will check for the all the connected nodes basically, right? So if you want this code, then you can just comment below the video. I'll provide the link, and you can access the C++ code there from my GitHub account. So let's build this one. So yeah, build is done successfully. So now let's run this exe, and it is saying asking for the use case count. So let's say one use case only. And the size of the matrix, the size of the matrix here is in the discussed example, whatever we discussed is number of rows is 4 and number of column is 2. So it is 4 comma 2, and here now enter the elements of the matrix. So it is 0 comma 1, then it is 1 comma 0, then it is 1 comma 1, then it is 1 comma 0, right? So this is the given matrix we entered, right? And here Iceland count is 1, right? So this is the one example. Now take the second example here. So again run, this time we will take the use case count 2, we will run the two use case here. The first is we will take the same matrix, but we will basically modify it one. So here let's take 4 comma 2, correct? And here it is 0 comma 1, then again it is 1. So instead of 1 comma 0, now this time we will take 0 comma 0, 0 comma 0. Then again we will take basically 1 comma 1 and 1 comma 0. So this time see here we see 2 count. Why 2? Because see here this 1 is surrounded by water only. So below and this all the 8 direction it is surrounded by water, because the this left side and this is the corner value, and this down, then this is right down and right side, left down and left side we are having water. So this is one Iceland, and the second one is one Iceland, right? And let's take another example here. So here we are taking 3 comma 3, and the value we will take this one, right? We will take this one. So here 1 0 1 0 and 0 0 0 and 1 0 0. Here we are expecting 3 Icelands. It should give 3, right? So let's enter this one, 0 1 0, right? And then 0 0 0 and then 1 0 1. So see here we are getting 3 as a output. So here what we will expect, what we are expecting here. So expectation is one Iceland is this one, one Iceland is this one, and one Iceland is this one, right? So if we run this one, then we should get 3 as a Iceland count. So we got 3 as an output, right? So I hope you understood the algorithms. We have discussed two approaches here, right? Using the recursive for finding the connected nodes, or using the dynamic programming, or you can say separate matrix where we will store the visited nodes. And for both of them, I have explained you in the code also. We have run the multiple use cases, right? This we have. This we have run, right? We got one answer. This use case we run, right? We got three answer. That's all from my side for today. See you next time. Till then, keep learning and keep exploring.